More sines and cosines today, except today we're going to deal with translations. Special name for horizontal translations is going to be phase shifts, and the vertical translation is just a vertical translation. So here's our standard formulas again. We see we have the A cosine k theta plus C plus H. We've already dealt with the A values and the K values. Those were more like multipliers. They affected how tall the graph went and how low it dropped. K talked about where the period was, whether it stretched the period out or squeezed the period in. Today it's H and C. H, which is outside of the sine or cosine function, is going to basically just move the graph up and down, so it acts as a vertical translation. C affects the sideways movement of the graph, and we call this related to our phase shift, although our phase shift is not C. All right, the phase shift is actually a combination of the C and the K value. So the phase shift is equivalent to the opposite of C over K. And what I like doing is I like factoring the K out, so I have a coefficient of 1 in front of my theta, and then my phase shift will actually appear right next to the theta. It's just whether it's positive or negative. So let's go through and do some examples. Our first example, we're going to identify this value right here. This value is going to be our C value, and in this case, we have a phase shift equaling the opposite of C over K, and we see our C value is a negative 50, and our K value is a 1. So our phase shift in this case is 50 degrees, which means it moves to the right. So I'm going to take and look at, once again, my period for a sine function, which goes from 0 to 360. My intervals, once again, are going to be my period, which is 360 divided by 4, representing the 4 quadrants. That's at 90 degrees. So I'll label 90, 180, 270. Except in this case, what's going to happen is my graph is going to be moved 50 to the right. So rather than starting at 0, I'm going to start at 50. And if I add 90 degrees to that, or add 50 to every thereafter, I'm at 140. Add 50 degrees over, I'm at 230. 50 degrees over from here, I'm at 320. And 50 degrees over from here, I'm at 410. So I'm going to graph a sine function from here. Sine starts at 0, moves up to 1, back down to 0, down to negative 1, and back up to 0. So graphing sine, I look very similar to this. So once again, I can take and do some checking. I'm going to check this value right here at 320. So what's the sine of 320 minus 50 degrees, which would be the same as the sine of 270, or negative 1. And that's my value. And so therefore I've graphed it correctly. So if I start at 50 degrees and at 410, there's my period of 360. And it reflects a translation of 50 degrees to the right. So in this case, we now have a value C equaling negative pi. And if the phase shift, I'll abbreviate PS, is equal to the opposite of C over the K value, and K once again is 1, have a phase shift of pi. So we know our period, once again, is equal to 2 pi, and our intervals are 2 pi over 4 or pi over 2. So in this case, rather than start at 0 and go to 2 pi, I'm going to start where my phase shift is. I would normally start at 0, but now I'm starting at pi. Now, my intervals are pi over 2 from pi. So I add pi over 2 to this, and I get 3 pi over 2. Add pi over 2 to that, I get 2 pi. Add pi over 2 to that, I get 5 pi over 2. And add pi over 2 to that, and I get 3 pi. And I'm going to be graphing a cosine function from here. So the cosine normally starts at 1. Then it goes to 0, -1, 0, and back to 1 in its 2 pi period. And you'll notice I've gone from pi to 3 pi. So that is a period of 2 pi. And this should be my graph. Again, I'm just going to check real quick a random point. I'll check this point here. That's the cosine of 2 pi minus pi, which is the cosine of pi, which I know is -1, and it checks out. Let's do another graph. So in this case, you'll notice this value is not within the cosine function. It's kind of outside, even though there's not parentheses. So this is a k value. Since it's a -3, all that says is my graph will be vertically translated down 3. So here's how I'm going to graph this. There's no period change, and there's no phase shift. All that's happening is my graph is sliding down 3. So you'll notice, typically we have this thing called a midline, or the line that divides the sine or cosine function in half. And that midline is usually that axis. But in this case, what's happening is all my points are sliding down 3. So what I'm going to do is I'm going to take and I'm going to move my midline down to -3. And I'll put the midline in blue here. So this is the midline. My intervals are still going to be at 90 degrees. And my cosine function is going to act the same as it always does. So usually from my midline, I would go up at 0 degrees 1 to start my cosine function. So I'm going to move up here. Then I would go down to 0 or go back to my midline, go down to -1, come back up to 0, and finish at 1 above the midline. So if I graph this, I'm looking at a cosine function very similar to this. Again, what I'm going to do is I'm going to pick a point, all right, and this happens to be the point 180 and -4, and I'm going to see if that point checks out. So I have a cosine of 180 degrees, and then I'm going to take and subtract 3 from that. Cosine of 180 degrees is -1 minus 3 equals -4. Checks out. Again, we have a midline change in this case because my k value is equal to 1. So I'm going to draw my standard midline. We'll go from 0 to 2 pi this time just to change up units. No period change, so my intervals are still going to be pi over 2. And rather than going from 1 to -1, I have a k value of 1, which means I'm sliding up 1. So in this case, we will draw our midline right at 1. And normally sine lines right on that midline. So in this case, my sine value is like 0. Then I move up 1, down to 0, down to -1, and back up. So in drawing the graph, here's my translated sine value. And I'm going to check another point, specifically this one here. We'll find the sine of 3 pi over 2 and then add 1 to it. Well, the sine of 3 pi over 2 is -1. Add 1 to that, and I get 0, and that point checks out. All right, we're going to start combining things now. Now, as I stated in the first slide, my preference is to put a 1 in front of my theta value. So right now what I have is I have sine of 3 theta. I'm going to pull that 3 out. And if I factor out a 3, I'm left with theta minus pi over 3. Now, if I put my function in this form, this here is actually my phase shift. So what I'm going to do is I'm going to slide to the right pi over 3 because it's negative c over k. 3 deals with my k value. So my period is equal to 2 pi over k. And now my intervals are equivalent to my period, which is 2 pi over 3, divided by 4, or times 1/4. So that's going to equal pi over 6. So now what I'm going to do is I'm going to say, well, what I want to do right now is I want to start where this is translated to. So I'm going to start at pi over 3. My period is 2 pi over 3. So if I add 2 pi over 3 to pi over 3, I get pi. And this is where I'm going to end up. Now, my intervals are pi over 6. So I'm going to change this pi over 3 to 6. That's 2 pi over 6. And then I'm going to add a pi over 6 to that every time. So if I add pi over 6 to 2 pi over 6, I get 3 pi over 6. And I could keep that as pi over 2 if I want, but I'm not going to. Add another pi over 6 to that, I get 4 pi over 6. Add another pi over 6 to that, I get 5 pi over 6. And if I were to add another pi over 6 to that, I get 6 pi over 6, which is pi, so I've done my intervals correctly. Now, since there's no amplitude change, I can move from 1 to -1 on my y values. This looks just like a sine graph, so I'm going to start at 0, move up to 1, down to 0, back down to -1, and back up to 0 again. Draw a sine graph, and I always check a point. So I'm going to check the 5 pi over 6 point here and plug it into this function. I'll go back into the original. So I'm going to take the sine of 3 times 5 pi over 6, and I'm going to subtract pi from that. So 3 times 5 pi over 6 is basically the same as the sine of 5 pi over 2 minus pi, which is the same as sine of 3 pi over 2. I know the y value at 3 pi over 2 is -1. And that checks with what's going on in my graph, so I've done it correctly. Note again, it's important to get the proper form first, and I prefer this form. You can do it whichever way you want, but this is the way I'm going to teach it. Let's move to the next example. Again, we have a phase shift and a period change. We're going to restructure this equation, put it in a proper form. I factor out the 2, and I'm left with theta plus pi over 4 after factoring it out. This gives me a phase shift of pi over 4 to the left. My period is equal to 2 pi over the k value, which is 2, so my period's pi, and my intervals are equal to the period divided by 4. So notice, I have a phase shift of pi over 4 to the left. So I'm going to start at negative pi over 4, because that's a phase shift from 0 of pi over 4 to the left. Then I know I have a period of pi. If I add pi to negative pi over 4, I end up at 3 pi over 4. So that says a whole cosine graph is going to happen from negative pi over 4 to 3 pi over 4. And then I'm going to label my intervals by pi over 4. Add pi over 4 to negative pi over 4, I get 0, pi over 4, 2 pi over 4, and then 3 pi over 4. From there, I'm going to graph a cosine function with no amplitude change. And then graph it. Once again, check a point. We'll check the point pi over 4. I usually check the points where I have a 1 or a negative 1 rather than a 0, because there's 2 possibilities of zeros. So I plug that in, and I get the cosine of 2 times pi over 4 plus pi over 2, which gives me the cosine of pi over 2 plus pi over 2, which is equal to the cosine of pi, which equals negative 1. So it checks. Next example. So now, somewhat of a similar problem. I rewrite, and I get y equals the cosine. I factor out a pi over 2. Left with theta plus, let's see, it's going to be 2, which means I have a phase shift of 2 to the left. My period is equal to 2 pi over k, which is pi over 2, which is actually 4. For my intervals are 4 over 2. Actually, I lied, 4 over 4, which gets me intervals of 1. I'm moving 2 to the left, so I'm going to start at negative 2. And I have a period of 4 in intervals of 1, so negative 1, 0, 1, and 2, and my whole cosine graph will appear over this period of time. I'll graph cosine, which means my initial value is 1. Then I go to 0, negative 1, 0, 1. Check once again. I'll check the point 0, negative 1. Cosine of pi over 2 times 0 plus pi, which is the cosine of pi, or negative 1. Once again, checks. All right. Can't get much harder than this. We've got everything happening right here. We have an amplitude of 4. We have a vertical translation of negative 3. Going to rewrite the function. So this is going to be 4 sine, pull out my half. I'm left with theta plus, I believe it's pi over 2 minus 3. So this means I have a phase shift of pi over 2 to the left. My period is equal to 2 pi over my k value. My k in this case is a half. So 4 pi is my period. My intervals are equal to 4 pi over 4 or pi. So here's what I'm going to do in this case. I'm going to start by saying, well, what are my horizontal values? I have a phase shift of negative pi over 2, so I'm going to back up pi over 2. And I'm going to have intervals of pi from there. So if I add pi to pi over 2, or to negative pi over 2, sorry, I get positive pi over 2. If I add pi to that, I get 3 pi over 2. Adding pi to that, I get 5 pi over 2. And adding pi to that, I get 7 pi over 2. And that is going to reflect one period of this sine function. Now my y values are going to fluctuate between 4 and negative 4. However, all right, in this case, I have a vertical translation of negative 3. So what's going to happen is my midline is going to move down negative 3. And if I move up 4 and negative 4 from there, I get values of 1 and negative 7. So notice how I'm going to graph this now. Normally sine starts at 0 or on the midline. So here's my midline in this case. Then it moves up whatever the amplitude is. In this case, the amplitude is 4, so I'm going from negative 3 to 1. Goes back to the midline, down the amplitude. So if I'm starting at negative 3, I'm moving to negative 7, and then I'm back to my midline. So here's my graph. And let's check a point once again. I'm going to check the point 5 pi over 2 and negative 7 by plugging into my original function. So I have 4 times the sine of a half times 5 pi over 2 plus pi over 4 minus 3. So this is 4 sine 5 pi over 4 plus pi over 4 is 6 pi over 4, which is 3 pi over 2 minus 3. 4 times the sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1 minus 3 equals negative 7, and it checks out. That's about as rough as it's going to get. Let's do one more, and then we'll call it a day. So we take now negative 3 cosine, factor the pi out. We're left with theta minus 1/3, and add 1 to it. Amplitude, we'll call it a negative 3. Just means we're going to take and reflect over that horizontal axis. Vertical translation equal to 1. Phase shift is 1/3. Period is 2 pi over k, which is pi, or in this case, 2. I now have intervals of 2 over 4 or a half. All right, now this will be a little bit trickier in as far as outlining where my horizontal points are. I start at a third. And what I want to do is I want to add a half every time. But since I'm starting in thirds and I'm adding halves, I probably ought to just put everything in sixths. So I'm going to say that this, instead of a third, is 2/6. And what I will do every time is add 3/6 to that. So if I add 3/6 to 2/6, I have 5/6. Add 3/6 to that, I get 8/6. 3/6 to that, I get 11/6. And 3/6 to that, I get 14 over 6. And if my period's supposed to be 2, and I started at 2/6, well, notice I have 12/6 in between there, which is 2. So I'm good to go. Now, in this case, I have a vertical translation of 1. So this yellow dotted line will reflect the midline, which is happening at 1. From that 1, I'm going to be moving up and down 3. So I'll go up 3, which puts me at 4, and down 3, which puts me at -2. And I'm going to graph a cosine function. Instead of starting cosine at 0 and then up to my amplitude, I have to multiply the y values by -3. So I'm starting down this time. Then I'll go to my midline at my first interval, up, back to my midline, and down. And I'll take and graph that. Again, I like checking a point, so let's do that. Take -3, cosine. I'm going to use my 8/6. So in this case, I'll have the cosine of 8/6 is 4 pi over 3 minus pi over 3 plus 1. That's -3 times the cosine of pi plus 1. The cosine of pi is -1 times -3 is 3 plus 1 is 4. What do you know? All checks out. So let's skip this example. I think you can handle it. Let's move on to our questions for the day. And here are the first two. The last one is right here. It's a little longer today. Hopefully you got through it all right. We'll see you tomorrow.